Hey, ladies and gentlemen. In this video, we are going to identify the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range of each function. All right, I want to remind you, these are in the form of y equals a parentheses x minus h close parentheses squared plus k. All right, h comma k is our vertex. A is related to the slope. It's not the exact slope because these are curves and not straight lines. All right, this is called vertex form. Now, first thing we're going to do is identify the a, the h, and the k. So a is 1. H is, well, negative h equals negative 1 is positive 1. So positive h will be negative 1. And k is negative 6. Alrighty, now our vertex is h comma k. That's why they call this vertex form. And so that means it is negative 1, negative 6. That is the point of direction change in our curve. Let's see, the axis of symmetry. I like to abbreviate it as AOS, axis of symmetry. It is the vertical line, x equals h. Well, h is negative 1, so that means it is x equals negative 1. That is your axis of symmetry. Your maximum or minimum value is always related to your vertex. I'm going to go over that one after I have drawn the graph, and I'm going to do the domain and range after I've drawn the graph. So let's get the graph of our red function up here. First thing you always do is plot your vertex. Okay, and I am going to do a table. So our vertex is negative 1, negative 6. All right, each of these marks is 2 units because every square is 1 unit. So I go left to negative 1 and down 2, 4, 6. Why do I have these marks like this? It's just so my eyes don't go crazy with all these tiny little grid squares. Alrighty, no major anythings on that. Now let's plug in 2 numbers to the right, so 0 and 1. And then we will also plug in 2 to the left, which are going to be negative 2 and negative 3. Always go to where your vertex is and pick 2 values to the left and 2 to the right. Okay, so plugging in 0. 0 plus 1 is 1. 1 squared is 1. 1 minus 6 is negative 5. So I plot the point 0, negative 5, right here. All right, plugging in 1. 1 plus 1 is 2. 2 squared is 4. 4 minus 6 is negative 2. So I go right 1 down to negative 2, plot my point. Then plug in negative 2. Negative 2 plus 1 is negative 1. Negative 1 squared is positive 1. 1 minus 6 is negative 5. You notice these repeat. Why? Because they are symmetrical. So that means at negative 3, I am going to get negative 2. So it's kind of like a twofer. You apply 1 point and you get 2. So at negative 2, I go down to negative 5. Put my dot. And then at negative 3, I go down to negative 2. Connect with our U-shaped curve. And here is our parabola. All right. Now, if you have to draw the axis of symmetry, it is just a vertical line, x equals negative 1. So I just go here and I use a dashed line. I just make little dashes on the vertical line, x equals -1. And that is my axis of symmetry on this one. Okay, now we also have to find maximum and minimum. Well, you notice this opens up. When it opens up, we don't have the top of a hill, we have the bottom of a valley. So our vertex is where the minimum is at. Okay, the minimum value is the the y coordinate of the vertex, and it is found at where the x coordinate is. So we have a minimum value of -6, and it is located at x equals -1. When in doubt, just give the coordinates of your vertex, -1, -6, and write the word minimum. That just tells that you know it's down there at -1, -6. Okay, but the maximum minimum value is technically the y values. All right, domain and range. Well, domain is going to be all real numbers. How do I know? Because I can pick any number I want, plug it in for x, and get an answer. Okay, it might be a very big number, it might be a very small number. I can even pick 0. So your domain is all real numbers for these. Domain, all real numbers. All right, now if we were writing this in a set builder notation, we could write it like this. We have a set of real numbers such that our variable is x, such that x would go from -infinity less than, actually we can't say equal to, so let me undo that, less than x less than positive infinity. All right, and this can also be written as this, parenthesis, -infinity, comma, infinity. That is another way of stating your domain. You may see it written any of these three ways. Now in Algebra 2, we will generally use the words all real numbers. But in like calculus and pre-calculus, you would use it either of these. Okay, now let's look at our blue one. Oh, I forgot our range. My bad. You notice we will never get any points below -6. So I am going to say my range y is greater than or equal to the y coordinate of your vertex, -6. Okay? Oh, by the way, this is called interval notation right here. All right, let's look at the blue one. Okay, first of all, identify A, H, and K. A is -1/2. H is going to be 4, because you always have to change the sign. K equals 12. All right, your vertex is going to be at 4, 12. All right, this is going to open down. How do I know? A is negative. Okay, now the axis of symmetry, the AOS, is the vertical line, x equals h, so x equals 4. And let's see. Because this opens down, it's going to open upside down. We're going to have a top of a hill. So we will actually have a maximum value. So when the parabola opens up, you have a minimum. When it opens down, you have a maximum. So we have maximum value of 12 at x equals 4. Our domain in range. Well, I'll wait to do that until after you've seen the graph because it might make more sense to you. So let's plot our points. So we have our x and y. Okay, our vertex is always our first point, so that means we have the point 4, 12. All right, now let's see, 2, 4, up, 2, 4, 6, 8, 10, 12. Right there. That's our maximum point. See, it opens down, so everything's going to be below that. Now, I'm going to just choose some even numbers. Why? Because of this 1/2. I don't want to end up with an odd number and then taking half of it, then I mess with fractions. So choose even numbers. So to the right of 4, we could do 6 and 8. To the left of 4, I could do 2 and 0. All right. There is no law that says I have to count by ones. I could count by twos by what I plug in. All right. If I plug in 6, 6 take away 4 is 2. 2 squared is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 12 gives me 10. So we have the point 6, 10. What's really nice is when I plug in 2, I should get the same number. Why? Because they're symmetrical. All right, plugging in 8. 8 minus 4 is 4. 4 squared is 16. Negative 1/2 times 16 gives you negative 8. Negative 8 plus 12 gives you 4. And at 0, I will also get 4. So let's plot our points. So we had our 4, 12 right here. So we have 6, 10. Now you notice this one opens up wider. Why? Because that negative 1/2 in front, I have a vertical compression by a factor of 1/2. And then 8, 4 is our next point. So 2, 4. See, this parabola is going to open up fairly wider than the other one. All right, then we have the point 2, 10, which is right here. And then 0, 4. Okay, connecting our dots. I kind of missed that one a little bit. You get the point. Okay, our axis of symmetry is just the vertical line that goes through our vertex, which in this case it is x equals 4. And then we need to do domain and range. Our domain, all real numbers. Okay. Why? I can pick any number I want. Okay, our range. Well, our range, since we have a maximum value, everything's going to be below 12. So it's going to be y is going to be less than or equal to 12. And there we have it. All right, happy graphing. Enjoy those parabolas in vertex form.